All right, so good morning. So my name is David Widegren. I come from a place called CERN, which is the European Organization for Nuclear Research, located in Geneva, Switzerland. So some of you might read, nuclear research sounds really complicated, and I can just agree, it is really complicated. But the thing is, the good news is that I will not talk about research here today. I'll talk about the management of the assets required to do this research. What you will see is also not that obvious. And I'll show how we use EEM and IoT to make the most out of our assets. And that's very much my job at CERN. So I'll spend a little bit of time just showing what CERN is, because it's kind of fun as well to show what this is, because it's a bit different compared to most of your industries. Set the scene for asset management at CERN. Our platform is used for EEM and how we streamline those processes by combining EEM and the industrial IoT. So quickly about CERN. CERN is the largest research center for particle physics in the world. So we're funded by 21 member states in Europe, and then another basically 100 countries around the world collaborating together and funding this organization. So of course also the United States of America is one of the major collaborators in this big organization. So what we do is that we provide scientists from all around the world with means of studying the smallest building blocks of nature and try to explore things like the origins of the universe. Well, it's kind of easy peasy questions to solve. So what we do is to build and operate large scientific instruments that we call particle accelerators. And to do this, well, we need lots of people, and we need some money. So on a given day at CERN, we're about 12,000 people on site, and the operational budget is about $1 billion per year. So even if what we do at CERN is physics research, our main, that's really our main purpose, why we exist. But sometimes we have to push technology to what's beyond possible. And there's some spin-offs coming out of this that are applicable in daily life, like this thing here. Anyone knows what this is? Yeah. Well, it's a next box, but it's not the thing. It's more fun what it was used for. Because in fact, it's the world's first web server. So the web was invented at CERN in 1989 as a way to share information between institutes collaborating together around the world. And this was the first web server. And it's a bit funny if you see the text on this sticker, those in the front here says, this machine is a server, do not power it down. Because if you did, you literally switched off the web for the first few years of the lifetime. Okay, so do not touch. So what we do today is that we run this thing. The Large Hadron Collider, the LHC, is possibly the largest and most complex machine ever built by mankind. Some clever people like Stephen Hawking who says it's probably the most complex machine in the universe, but I don't know. If he says so, it's probably true, but it's very complicated anyhow. So it consists of something like 100 million components put together, just here outside Geneva, Switzerland. So here we have Geneva. Here we have the best skiing in Europe. So here is the machine. So it's located about 300 feet below ground, a 17-mile circular tunnel, where we then shoot particles around very, very fast. So they do the 17 miles, they go 11,000 turns per second. Okay? So we saw the Formula 1 cars here yesterday. This is even quicker. Okay? So we shoot particles around here, and at very precise points, we collide them. Okay? So particles will come in this direction here, and in that direction here, and boom, they create a small Big Bang. Okay? And we actually recreate the universe like it was just a fraction of a second after the Big Bang. And we do this 600 million times a second. Okay? So in here, it gets really warm. It's about 1 million times the temperature of the center of the sun. And then particles goes in all direction. And this is then a big, say, an onion, but it's an onion with different layers of sensors that captures information about those particles. So we capture about 1 terabyte a second in here in total of data. And you can see those things here, those are not ants, those are people, just to show the size of it. Okay? So it's 1 out of 4 detectors will collect this kind of information. Okay. So the thing is, we have some assets to manage at CERN. So some of them are the accelerator complex. It's really complex, to put it like this. And the thing is as well, well, here we see, by the way, the tunnel. So that's the 300 feet below ground. And in this below tube, that's where the particles go fly by, very, very quickly. And it's just to say, it's not a blue tube. It's a superconducting magnet cooled down to 1.9 Kelvin. That's 1.9 degrees above absolute zero. So in fact, it's the coldest place in the universe. It's outside Geneva. So I think it's quite fun that I can say I work at the coolest place in the universe, and I can prove it. Okay? So we have very specific equipment, but we also have a whole set of technical infrastructure to maintain. We have roads, we have electricity, we have pipes of water, all these things. It's like a small town, okay, that we have to manage as well. And our strategy at CERN is to have a single EM system to manage this. We have a single software to manage the whole site and the accelerator, which in this case is Info-EM that we use to this throughout the whole organization. So I just want to highlight this very wide array of different types of assets we manage at CERN. So we have, of course, the accelerator, which is quite unique, but we have also then big cryogenics installations. It's the largest cryogenics installation in the world. We have, of course, like many of you, have cooling and ventilation, traditional installations. We have electrical installation. We hooked up to both the French and the Swiss national grid to get some power to the machine, because it consumes some electricity as well. We have data centers. We have an antimatter factory. I guess you don't have that on your site. And if something goes wrong there or elsewhere, we have a fire brigade that can help us, that we have to manage as well. And we have to manage the whole small campus that we have on site with the 12,000 people on site. So the thing is here, our strategy, as I said, is to have one single place to manage all this. And something that I'm quite proud that we managed at CERN is that we have done this without modifying the software. We have not done expensive customization. We have close to zero modifications of this software, which means that we're in quite good situation when it comes to upgrades and maintaining this on a long-term basis. I've seen many cases at CERN and elsewhere, we kind of tweak software inside out to do what they should do for us, what we think they should do for us. And it often gets very expensive in the end. And my take on that is basically, if that's the case, well, probably your processes are a bit too complex. Perhaps you should review your processes, or you're simply using the wrong tool to do what you're trying to do. Okay? So the assets we have at CERN, they have a life cycle of way beyond 50 years. So many of the accelerators we have in the whole chain of accelerators at CERN were built in the 50s, 60s, and 70s. So they are aging equipment as well. And in this lifespan here of our accelerator components, for example, is basically one generation of people designing and manufacturing the equipment, and another generation, or the following generation, operating and maintaining them, which means that documentation and logging what's being done is extremely important. So in our case, a big chunk of the maintenance is also outsourced, because we simply cannot have all the people employed by CERN by different constraints linked to cost mainly. So it becomes even more important to actually have a single place where we log all the information about our assets, because like in your cases, outsourcing is good to a certain extent, but you also risk to lose some kind of hands-on knowledge, what's happening to your assets. Okay? So in our case, we really open up our EM installation both for CERN personnel and for contractors. So everyone is working with the same tool, and we make sure that everything is logged, what's being done. Some people then often ask, okay, David, how do you get your contractors to report what's being done into your system? Well, in our case, it's been quite simple. We simply say, if you don't do it, we don't pay your invoice. And it works great. So put it in the contract and it will just work. And for us, also a key thing here is that if we have a common tool throughout the whole organization, well, we have common ways of working, and we can draw some significant financial savings and operational benefits out of this the scalability of all this. So in our case, we put together a kind of integrated platform around asset management where we put our EM application in the middle. But we also, of course, link to the operations, control rooms, different SCADA tools, network equipment, IoT to collect information on what's happening in the field. Also linking back to our design. So we have our PLM system, our product lifecycle management tool, where we have all the design information, linking back there so we can trace back if something goes wrong. Why did it go wrong? Do we have other components designed in the same way? Putting together all this thing into one integrated platform. By doing this, we have plenty of people working with the tool. And that puts some new constraints to it as well. Because we have quite different kind of people working with one and the same platform, but which does not mean that they have to use the same user interface to access the information. Because what we've seen and probably learned the hard way is that different profiles have different needs in terms of software and accessing information. So some people need a full-fledged thing, others need to go mobile, others need to have stripped down versions of the tool to access the information or simply consult simple stuff. We have seen that this kind of simplified and mobile interface has been a key to success at CERN, and without this we would not have been able to implement anything of this. So simplification is kind of a key at CERN. And this guy here said it very well. If you can't explain it simply, you don't understand it well enough. And it really applies also to software and implementation of EM tools, or control software if you want. Because the thing is, very few people need to have an interface cluttered with functionality and data, at least not at a given moment. They might need it, but not all the time. Okay? So you have to scale down and strip off things that you don't need in those interfaces to make it usable. So you need capable tools, but you need simple user interfaces. And especially when you work with something complex like we do with CERN. So yes, some numbers just to show that with the scale of the installation at CERN, some 2 million equipment soon, growing quite rapidly still, backtracking the old accelerators that have not yet been in our maintenance management tools. We have some 150,000 work orders per year, lots of documents, a bit of users, and integrated to a whole bunch of different tools around in our IT infrastructure. So now, linking a bit more to operation, we have, this is the CERN Control Center. It's really the heart of the whole operation at CERN. So in here, we have people 24/7, all days of the year. Even on Christmas or New Year's Eve, they are in here. And in here, well, you have a bunch of screens, of which many you have a whole bunch of alarm screens, which are kind of a consolidated view of information coming from either networked equipment, from SCADA systems, or from other databases around the accelerator. What we said here is that in many cases, we could push information here about problems directly to our EM. But we have decided in many cases not to do it automatically, but that we want to put an operator in between to see if it makes sense to send someone there or not. Okay. So what we've done is to make it as simple as possible. So we have kind of a one-click operation saying this operator in the control room says, yes, we have to send someone there, and it's one click, it goes to our EM, and the team, either internally or externally, can be going to this faulty equipment. So what we have done to simplify this as well is that when declaring new alarms on the operational side, often we have put it's mandatory to define which equipment on the EM side does this correspond to. So you're not allowed to declare alarms in operations if they're not pointing to an equipment on the EM side, which makes this thing much easier later on. So some extra work up front, but downstream, lots of benefits. And of course, those kind of automations, if you have a large volume of information, it's essential. Another fairly stupid example, if you want to compare to the different equipment we have at CERN, is elevators. Well, we have elevators around the ring to go down to the accelerator and also to get out if something goes wrong. So it's a quite important thing. So in here, it's something we didn't do that long time ago, because we're kind of focusing on the more complex equipment at CERN. But what we realized is that in this case, the lifts or the elevators to go down to the machine were kind of critical equipment to have availability of fixing the advanced stuff down in the tunnel. So we simply here hooked up one of our SCADA tools, SCADA systems with EM, pushing meter readings, so traditional classical thing of doing things. But what we were a bit surprised were that we could actually cut, in many cases, maintenance with 50%. We were maintaining much too much, and also increasing the availability of those critical assets with a significant percentage during shutdowns. So when it comes to the streamlining of the operation here, we have loads of connected accelerator equipment, okay? So that pushing data to our control room in all kind of ways through either directly or via different SCADA tools. And then a much thinner arrow of data goes into our long-term logging of data. So this thinner arrow of the most important stuff is still quite a bit. So we have some 1.4 million data points in here, and we collect about 0.5 terabyte of data per day about how the assets in the accelerator perform. So we're growing quite quickly. So those were the numbers when I left CERN last week, so it's already a bit more, but it's fairly up to date. And we have some 5 million requests every day where people do analytics on this, trying to understand why the machine is behaving like it should, or like it does. So the thing is here, what we have seen, and what I think we all have seen in the past, is that it's quite obvious that industrial IoT can facilitate EM and maintenance management and better asset management. You can have equipment raising a flag saying, hey, I'm not feeling well, come and fix me. Or you can do predictive maintenance and so on. But we think that also could work the other way around, that EM can really facilitate more efficient industrial IoT. Because now with the IoT revolution, which is really a revolution, we can get so much more data, okay? It gets more affordable, we have much more information coming. And the thing is, with all this data, we get a bit lost in the whole noise of these big data noises, as I call it. And the thing is, with the help of EM, or the information in the EM, we can then start filtering what's important and what's not important from a maintenance perspective, from an asset management perspective, not just purely operational performance. So we can, based on the risk and risk analysis down on the EM side, or we can do it based on the cost, how much money do we spend on maintenance, and try to see what should we actually be looking at on the big data side and the analytics side of things. And we believe that by this intersection of IoT and EM can really help us going from the big data analytics to real data analytics, because big data is good, but the data itself is quite useless if you don't know what you're looking for, okay? So we think that by combining the information coming from our operational side with the maintenance information and asset management information we have on our EM side, we can really do quite a bit of things of improving performance and availability of our installations. And this is something we just started at CERN, so it's something which is quite new, but we really strongly believe this is the way forward. So, conclusions there is that we have been using a commercial EM tool from Infor for over 25 years. We're continuing extending the use of this very rapidly throughout the whole organization. This is today our central hub for both technical and financial management of assets. And by combining now the enterprise asset management with the industrial IoT, we're quite sure that we can increase uptime and optimize the performance of the accelerator, which in turn for us is really the way forward to new physics discoveries that can, in the end, actually change our understanding of the universe, how things work, and so on, and our perception of the world for the future. And perhaps as a little bonus, it might lead to some Nobel Prizes on the way. So that wouldn't be so bad either. So, okay, that's all it. Thank you very much for listening.